Hello everyone, this is Soundarya from Sri Venkateswara College of Engineering. Today we are going to discuss few topics about 2D pipeline, 3D pipeline and some colors in computer graphics. In computer graphics, 2D pipeline refers to the series of stages and the operation involved in rendering 2D graphics on the computer screen. It encompasses a various processes such as geometric creation, transformation, rasterization, and rendering. Here, a high-level preview of the typical 2D pipeline. Geometric creation is the first type. The first step is to define the geometric shapes that we will render on a screen. This can include creating a points, lines, curves, and polygons using a mathematical equation or input from the user. Transformations, once the geometry is defined, transformation is applied to the position, scale, rotation objects in 2D scene. This transformation include translation, rotation, scaling, shearing, operation, etc. Third one, we have clipping. Clipping is a process of removing any objects or parts of the objects that lie outside the viewable of other objects. It ensures the visible portion of the scene is processed further. Rasterization. Rasterization is the process of converting the geometric shapes into the raster image format suitable for display on screen. This involves determining which pixels within a viewport and convert by geometric primitive assigned appropriate color and attributes of those pixels. Next, we have texturing. Texturing involves applying images or the patterns onto the surface of objects. This can add the details, colors, or patterns to enhance the visual appearance of the scene. Texture coordinates and typically assigned to vertical and geometry of the control how the texture mapped onto the objects. Next, we have a fragment operation. Fragment are individual pixel resulting from rasterization. Fragment operations are performed on each fragment, including the operations such as depth testing, alpha bending, shading, and etc. This operation determines the final color and transparent of each pixel on the screen. Next, we have a composition. Composition, finally, the compositor combines all the fragments and renders them onto the screen. The order of bending of fragments and determined by factors like depth, transparency, and bending functions. It's important to note that the pipeline described above is specified overview and actual implementation may vary depending on the graphics and API or format work being used. Certainly, now let us study about 3D pipeline. First, we have modeling. Objects creation in modeling will do. The process starts with creating the 3D objects using the modeling technique such as polygon modeling, spin-based modeling, or procedural modeling. Object manipulation. Objects can be transformed, rotated, scaled, and positioned in the 3D space using various transformation operations. View and camera setup. Camera placement. The virtual camera is the position and oriented to define the view of 3D scene. Perspective, projection, and 3D scene in projected onto 2D viewing plane defined by the perspective field of view. Next, we have a clipping and culting. Clipping objects or parts of the objects that are outside the viewing frustum or clipped to ensure using a visible portion or processed back back face culting surfaces faces or facing away from the camera are culted to improve efficiency. Next, lighting and shading. Lighting calculation. The effect of light surface resources or the objects are computing to determine the elevation and shading of object pixel or vertex. Surface shading. Technique like a flat shading, ground shading, or palm shading are used to determine the color or the attributes of each pixel or the vertex. Projection and transformation. Model transformation. The object vertices are transformed from their local coordinate system to the world coordinate system. View transformation. The object are further transformed into the camera or view space. Next, we have projection transformation. The objects are projected from view space to a screen space using perspective or orthogonic object projection. Rasterization. Triangle setup. The 3D primitive typically triangle are set up for the rasterization. Scan the conversion. The triangles are converted into the fragments or a pixel or determined which pixels are covered by the triangle and interpolated object attributes across the triangle. Texturing, texture mapping. Texture are applied to surface of the objects to add detail, color, or pattern using texture coordinate assigned to the vertices. Texture interpolation. The texture coordinates and attributes are interpolated across the triangle and determine the texture values and fragments. Next, we have a fragment operation and we have a display. In the given below diagram, like this, we can determine it. We have a modeling here. We have a modeling, then we have a view